Hello my people and welcome. So for this particular video, I will show how to determine the oxidation number of any particular element where if you see in a given compound. So wetin that one mean be say e get some rules you go need know. So I go dey state the rules one after the other. For this video, I will just state only one rule and do maybe two examples for you. Now, for rule 1, if they say make you find the oxidation number, the oxidation ma use ON to represent oxidation number. If they say me find the oxidation number of sulfur of sulfur in S sub 8, remember we define the oxidation number of sulfur in this particular molecule of sulfur. Now the first rule be say the oxidation number, write am down. Rule 1, the oxidation number of a free element. Free element, you know wetin be free element? Anytime we hear of free element, we mean say uncombined element wey no join with any other thing, e just dey on im own. Like e could be sodium, e could be sulfur, e could be oxygen, e no join with any other thing like the way we go get hydrogen and oxygen to form water. No, uncombined element means, or free element means uncombined element wey just dey on im own. So I say the oxidation number of a free element, which is uncombined element, is 0. Take note of that one. Is 0. Write am down. It's very important. Is 0. So wetin that one mean be say, now for this question wey dey say make we find the oxidation number of sulfur in sulfur molecule, this is S sub 8. Now wetin you go come do be say sulfur normally get this crown shape. E get crown shape. Crown, you know king now wey dey wear crown, crown shape na this sulfur get. But normally we no dey talk about the shape now, make we leave that one. But anytime we see S sub 8, this thing dey talk about molecule. This one na molecule. Is a molecule, no be atom of sulfur be that, na molecule. Because of this, even na 2 wey dey sub or na 3, na molecule e don become, no be atom again of sulfur. E don become molecule. So just be like say they get S plus S plus S plus S plus S up to 8 times. So no be atom again, don become molecule. Even if na 2S only self wey add together to give you S sub 2. Shey you understand the point now? So now S sub 8 now, I say na wetin? I say na molecule. And S, ordinary S like this, na free element. Now S, why they talk about the free element now, wey be kind of oxygen, sulfur, we no get anything attached to them. S is a free element. A free element. And if you check this S now, you no even get charge. Charge no dey am. Like on top here, you get plus or minus, no charge. Charge no dey. You get other question wey charge go dey o. Na make you need to subscribe to this channel, share this particular video if you want make I dey do more, make you sabi this thing well well. So wetin come be the answer as we don establish this one? E mean say the answer be say therefore the oxidation number based on wetin we don establish so far of sulfur in this molecule of sulfur is equal to 0. Remember this statement, the oxidation number of a free element is 0. So oxidation number of sulfur in this case na 0. Make you do one more. If they say make you determine the oxidation number of oxygen in oxygen gas O sub 2. Remember I tell you now, O sub 2 now is a molecule form of oxygen. This is a molecular form of oxygen. This O sub 2, if you write am down, is a molecular form of oxygen. Note say we need many atoms to get molecule. Wetin I mean be say we need many atoms to get molecule. Like this particular O2 now, this one na first atom, this one another atom. So these 2 atoms join together don give us O2, molecule of oxygen. So like that sulfur where you get plenty S to give us molecule. That's why we need plenty atoms to get molecule. So now these 2 atoms now don't give us molecule. So wetin come be the answer? Remember say oxygen na just element. Oxygen like this without the sub 2 na just element. So the oxidation number of this oxygen wey dem say make we find in this particular molecule na 0. So na this rule now I carry down explain these two questions. Now you don see say the oxidation number of free element is 0. Take note because there are a lot of rules wey you need to know. If this particular video don help you and you enjoy am the way I take explain am, just give me thumbs up, just hit the like button, subscribe to this YouTube channel, and try to share this particular video so that other learners now fit see am. And just make sure say you join my Telegram channel if you never subscribe to my Telegram class. I get structure classes there. I will see you on the next one. And the next one I will give you assignment. So make sure say you drop comment for this one. Make I see say you been watch this particular video. Oh yeah, now take care of yourself. Now you may be Instructor Alison, they teach math and science for Pidgin English. I will see you. People, and welcome back. So today we want to talk about the oxidation number of several elements. Now we don't talk about the rule 1 when we, if you never watched the video, just go check oxidation number. That one I no write one here, na me the first one, and now rule 1 you go see. So this one are the rule 2. Try go know the rule 1, just go find and watch that video. It's very important. I will link them up here. If you don't see them here, just go watch them for my page. They already. This rule 2, they talk about the oxidation number. The oxidation number of a simple ion. A simple ion is the charge of that ion. Is the charge of that ion. Now, as I talk like this, now plenty people no go understand this particular one. But make I explain now. Now, I said the oxidation number of a simple ion is the charge of that particular ion. Now, this ion we dey talk about, before I go explain that one in detail, ion has 2 types. This ion, it get 2 types. What are the 2 types of ion? Very simple. The first one is what we call the anion. Have you heard of anion? Negatively charged ion is called anion. Write it down because there is no time. Negatively charged ion is called anion. Now, what about positively charged ion? What do you think is called? Put this in the comment section before I finish writing. Positively charged ion is called what? Correct, cation. Good. Now that you know what the positively charged ion is and also what the negatively charged ion is, remember we have 2 types of ion, positively charged and negatively charged, and I've given you the respective names. Now the rule we are talking about now say the oxidation number of a simple ion is the charge of that particular ion. So with that being said, let's practicalize it. Let's solve 1 or 2 problems to demonstrate it before we move to the next rule. Now, if we are asked to determine, that's the first question. Remember, I promised to give an assignment on this one, or classwork, which you can smartly do it without having to think twice. Now, so then they take teach. If I teach, explain it like that, everything enter. You will see yourself, they solve everything. Determine the oxidation number of sodium. The oxidation number of sodium in sodium ion, like this. If you never see this one, at least don't see them for the first time. But if you don't see them before, fine. Our interest now to solve this problem. Now, if you want to solve this particular question, it's very, very simple. Oh. Anytime we see plus like this, it means in a +1. Oh. If you see minus on top here, it means in a -1. If you see +2, and a +2 be that. +3, as they go write them up. If it's a -2, then go write them up. But anything will be just only plus or only minus. Now the ion be that. Remember I said the oxidation number of a simple ion is the charge of the ion. Now the charge be this particular one on this. Now the charge of the ion be this particular one with there. So what it is saying at the answer? It's simple. The answer is +1. So the oxidation number of sodium in this particular sodium ion is this particular charge on it, which is +1. Very simple. Now question 2. I'll do extra one join before I give you classwork. Determine the oxidation number of aluminum in Al. Might just give this one as 3 plus. Al 3 plus. Wait till you see the answer. Remember this rule: the oxidation number of a simple ion is the charge of that ion. So it will be correct. You're correct. Plus 3. Plus 3 is the correct answer. Remember, say they always they stay and they go write like this: 3 before plus. All of now the system and the pattern of the way in the right time be that. Okay, this one I be your own. If you understand this thing, why I don't teach you now, I know say you don't happy right now because now so learning supposed to be. If you break everything down, students supposed to be am. So this one now determine the oxidation number of oxygen in O2 minus. What it is saying at the answer? Put that for comment section and then comment if this particular video help you well, and then try to share. If you never subscribe, hit the subscribe button because now like this we will take the learn chemistry. And if you're ready for oxidation number 3, like the rule 3, put that for comment section and they active to always help you fix this thing. Always write the charge. For example, is this say this one a plus, I write +1. I'm not just write saying a 1. Or this one 3 plus, I'm not just write saying just 3. I add the charge, the sign, join them. So always add the charge. The charge, they very very important. So now all I get for you for this particular video. If you know say this particular video help you, help me share them, help me like, hit the like button, give me thumbs up, and then hit the subscribe button, turn on the bell icon so that when I upload new video, you self go receive notification. And don't forget to join our Telegram platform where structured videos dey. Registration done dey on. Make sure say you register and join us and they learn. So now all I get for you today. Until next one, I go see you for the next video. Thank you so much for watching. Hello my people and welcome back. So my name is Instructor Alison, where they teach math and science for Pidgin English. So for this particular rule 3 on the oxidation number for this chemistry, we want to talk about the oxidation number of oxygen, particularly in most states. So remember say the oxidation, I just want to make you know this particular one, they're very important. The oxidation number of oxygen in most states na -2. So the oxidation number of oxygen in most states is -2. So you go see say most of the question you go dey solve when they say oxygen, you go see say the oxidation number of oxygen na -2 they put. Now why then they put -2 be that because the oxidation number of oxygen in most states na -2. But they get exception no. The exception na be say if na peroxide, make I write am down so that it will help you. Without is -2 without exception. Or without the exception, make I put am well, make you quick understand that. Without the exception of peroxide. So if no be peroxide, just know say peroxide. If no be this peroxide, because oxidation number of oxygen for this peroxide no be -2, that one na -2, na -1, which is -1. So what is this thing they tell you say oxidation number of oxygen in most states na -2, except for this particular guy when they call peroxide. When you reach peroxide, now always -1. But apart from this peroxide, maybe -1. I mean, when I talk about peroxide, I talk about hydrogen peroxide. You don't hear of that hydrogen peroxide now. For example, I'll put example, hydrogen peroxide. So hydrogen peroxide, now one of them, the formula now is it H2O2 like this. In this case now, put H2O2. In this particular case now, the oxidation state of this particular oxygen here now -1, because now hydrogen peroxide with this particular one. Even when they deal with potassium, if you write them in full, may I just write the short one, the formula of potassium peroxide like this. In this case, the oxidation number of oxygen now -1. Even if you talk about calcium peroxide too, calcium peroxide, the oxidation state of this particular oxygen here now -1. So apart from this peroxide, every other state where they deal with oxygen like that, the oxidation state of oxygen now -2. You go take note of them so that you know go fail any particular question. Sure, you understand? I hope say this one they very clear. So now if you want us to solve one or two problem inside this one, we go do them, because there's no way we go live without solving one problem. So if they say make you calculate question 1, calculate the oxidation number of sulfur in maybe SO2. Good. Now this one will be peroxide though. Remember I tell you say the oxidation number of oxygen in most states is -2. And anytime we want to calculate for oxidation number of anything, especially if you're determining the oxidation number of, say this one as sulfur, where they do that sulfur, now you go make them the element where they find, you go make them as your x. So in this case our sulfur na x. If for example na oxygen we dey find, we go make the oxygen x, but now na sulfur, so we go make that sulfur x, because now the oxidation state of sulfur now we dey find in this particular compound. So we go make an x. So x plus, now add you go do x plus, what is the oxidation state of oxygen? I don't tell you say the oxidation state of oxygen in most case na -2. But this -2 now you go multiply am by this particular subscript. If here na 4, you go multiply am by 4. If na 2, you multiply am by 2. You understand? Very very simple, very simple, and you go equate am to 0. Why we dey equate am to 0? Because you no get any charge. This formula no get any charge on top. If you get any charge, maybe -1 or -5, anything wey dey here, now you go equate am to that stuff. Na another rule be that. I go do am for the next video. So in this case, -2 times 2 will give us -4. So it can be x plus -4 equal to 0. Shey you know say plus times minus na minus. So you get x minus 4 equal to 0. Finally, if you define this particular x will be sulfur, then add 4 to both sides of the equation. Or that thing when I do say carry -4 cross go this side, change to +4. So x now will be equal to +4. So it means the oxidation number of sulfur in this particular compound now 4. Very simple. Very simple. And this 4 we talk now +4, and I tell you may always add this charge on the front of this stuff. +4. So now be the oxidation number of sulfur for this particular compound. Make I give you your own. Check the oxidation number of sulfur in this particular compound, S2SO4. Make I see whether you understand this particular question what I don't give you. I hope you learn for this particular video. Try share this video, make others benefit from it, and like this particular video. Don't forget to drop comment on which one you want make I do for you, and also make sure to hit the subscribe button, turn on the bell icon, so that when I upload new video, you self now you go be the first person to receive notification. And for this particular one I give you, if your answer give you, I think from what I done the calculate from my head now, it's supposed to give you 6. If your answer give you 6, it means say you did correct. But if you not give you +6, find out waiting they wrong. Very simple. So now all I get for you for this particular video. Until next time, I'll see you. Take care. Welcome to chemistry video tutorials. Here I want to talk about oxidation number. This is the part 4 of it, and then the rule 4. Now I want to make you understand, say the oxidation number of a radical. A lot of students they get problem with this particular one, so I want to fix them now. is actually oxidation number of a radical is simply the charge on the radical. Now I don't use English carry write and finish, make we break am down. Remember, since people don't know wetin this particular word radical mean. Wetin be radical? Radical na group of atoms wey dey behave as single charge. So if you write am down, radical, so na definition. Radical, I go use English write am. Radical is a group of atoms, like I don already define am already. Ma put am as radicals. Radicals are group of atoms which behave as a single charge unit. As a single charge unit. Now I'll get a couple of examples where I will show you. For example, if I get nitrate radical like this, nitrate radical NO sub 3, then get minus on top like this. Remember I told you, if you get minus like this, it means -1. If na plus wey dey here, it means +1. If na -2 wey dey here, you go know say na -2. Shey you understand? So this one they call am nitrate. This particular compound they call am nitrate radical. So you just imagine they're gonna ask me for exam, what is the oxidation state of this nitrate radical? I'll just tell them the answer na -1. Now make this rule say the oxidation number of a radical is simply the charge on the radical. Sure, you understand now? Very simple. So I don't tell you everything as it's supposed to be. It's very, very simple now. You know, you're even supposed to struggle for this particular one. So if they say I get the oxidation state of this one, I'll just tell them say the oxidation state of this particular nitrate radical is equal to -1. Let me the final answer for this one. It's as simple as A, B, C. So if I give you this one, what is the oxidation number of sulfate radical? Let me put sulfate radical like this, or maybe 2 minus. Just to say the answer now -2. Very simple. But if they say make you find the oxidation number of sulfur in this sulfate radical, you go know say you go equate everything to -2 to this particular charge. But then you go need to solve everything, which go come under another rule where I go show you. But I believe say this thing where I don't break down like this thing where I don't simplify like this one I count down, tell you bit by bit. You no get any single form of confusion inside them. I believe say you understand every bit of things where I don't talk inside this one. So one way to support this channel now to share this particular video, hit the subscribe button if you never subscribe, and make sure say you drop in comment section how you take understand them and any other topic where you want make I help simplify them like this. My name is Instructor Alison, where they teach math and science for Pidgin English. So if you know say this particular channel they help you, make sure say you support the channel in the best way we fit. Share this particular video to all the platform where you belong to on your status, and talk more about us. Thank you so much for your support. I will see you for the next one. Peace and love. Bye bye. Hello my people, and welcome to Instructor Alison online tutorial. So today we want to look at the oxidation number of several elements. Now, but the rule 5 I want to tell you now, rule we go take very seriously. If you never watch other rules, please make sure before I don't reach rule 5, you know say rule 1 to 4 already done day. So make sure say you like this video, subscribe, so that you go really they receive notification. How I want to take receive notification, and when you turn on that bell icon, now you go receive them. After you don't hit subscribe, the bell icon they very close to subscribe. If you never do and go do them, so you go receive notification. Now the first thing I want to talk for this particular, the rule I want to give you here now, we say the oxidation number of hydrogen. Now I want to focus on the oxidation number of hydrogen now +1. Just take note of them. Now +1. Now be the oxidation number of hydrogen. with exception. No, wetin be the exception? With exception, I just want me to know, just like as I tell you about oxygen, say na -2, apart from when it be peroxide, and now you go come say na -1. Na so way oxygen, hydrogen, the oxidation state of hydrogen na +1, with the exception. With the exception, wetin be the exception? Now when we talk about this one, na binary. When we talk about binary, exception of binary hydride. So this binary hydride, for example, the likes of the binary hydride wey I dey talk about na if you get CH, CaH2, this one na binary hydride. If you get something na LiH2, this one na binary hydride. Dey many, just know say because hydrogen normally na e dey more abundant. Na because e dey more abundant, so wetin go happen if, for example, now you wan ask the oxidation state of if you wan ask the oxidation state of binary hydride, hydrogen in binary hydride, maybe question just come say make you find the oxidation, make you find the oxidation state or number of hydrogen, oxidation number of hydrogen in any of the binary hydride wey I tell you. If they say me find the oxidation number of hydrogen in any of these binary hydride, e dey very very simple. Just know say the answer na -1 without you even solving. Very very simple, na -1. Since you know say this one Li na metal, Li na lithium, na metal e be, so the type of hydride wey dey for this particular one na wetin they call ionic hydride. The type of I no wan just go far, na make I just try to cut off some kind of information wey no go make us delay this particular video. So the main thing wey I dey try communicate inside this particular video be say anytime wey you see oxidation number of hydrogen, just know say na +1, except when e come to this particular binary hydride like this. Now you go know say no be +1, na -1. I think this particular, because they go state am for question, you go see am for question, obviously. I hope say this one don clear for you. So until next time, I'll come up with another rule. I still have more rules to go on oxidation number. This will help you to settle problems on oxidation number. You no go get problem about oxidation number at all again. So if you know say this particular video interests you, make sure say you like this video, share this particular video, and hit the subscribe button. Turn the bell icon close to the subscribe button so that when I upload video, you go receive notification. And drop in the comments if you get any other topic you want make I do, or if this particular one suits you, let me know for comment section. Now so we just take the run and small. Thank you so much for watching this particular video. I'll see you on the next one. Peace and love. Join my Telegram channel because we have structured videos on that particular Telegram channel for people who are planning for any form of exams. You need to be there. I'll see you on the next one. Peace and welcome to my tutorial. So today I want to show another very important rule when you deal with oxidation number, and this particular rule they talk about fluorine. So I want to make you know say the oxidation number of fluorine na -1. This one they happen in all compound, no exception, in all compound. Just know say the oxidation number of fluorine na -1. In case they say make you find, this thing will help you as quick hack to quickly answer questions for exam without any stress. Don't forget say I start this particular video with rule 1. Basically I don't already talk about oxidation number before, so I don't tell you say oxidation number, they just talk about the electrical charge found in an element. That's what is oxidation number, the electrical charge found in an element. It makes us to understand the oxidation number. That's so this oxidation stuff just be very simple. So if you use and get different oxidation number, if you sabi the rule, I don't talk about the rule 1. The rule 1 I talk about the oxidation number of free element. I tell you say na 0. I still talk about rule 2. root 3, root 4. I even talk about the oxidation number of hydrogen in the previous video, saying at +1, and I give some example and some exceptions to that, except binary hydride. All of those things are waiting you need to go watch to understand this stuff. I solve some problem. Even I ask you the next week, get one where I talk about the oxidation number of simple ion too. I talk about oxidation number of some radicals. I talk about oxidation number of oxygen in most cases. All of these things now rules where you need to go watch. If you never watch them, go watch them for the other videos so I don't post. And if you know say this particular one you find out interesting, just make sure to like this particular video, share this particular video, and make sure to drop in the comment section if you get any particular question where you want ask, or you get anything where interest you for this video where you watch. Don't forget to hit the subscribe button, turn on the bell icon, because now so you will take the receive notification anytime where I don't post a new video. Join my Telegram channel because I don't post a lot of videos, and then my private class too if you want join, because you get a lot of structured videos I don't do since last year. Thank you so much for participating in my class. I'll see you on the next one. Peace and love. Hello and welcome to Instructor Alison online tutorial. So for this particular video, I want to tell you about the oxidation number of a particular, now two rules now I want to join together, because now the last rule I want to give you, I'm supposed to do rule 7 and rule 8, but I want to join all of them together. So this will be the last video on the rules in this oxidation number. So this subsequent video will be solving problems upon problems upon problems. So this particular rule is talking about the algebraic sum of all elements in a compound. Know that it is 0. I'll give you two conditions. The first one is that the algebraic sum of all elements making up, or let me just start with the first one, the algebraic sum of all elements in a compound is equals 0. So you need to be familiar with this. For example, if I have this particular compound H2SO4, the algebraic sum of all these things, the algebraic sum, that means adding hydrogen plus this sulfur plus oxygen, even though I multiply them by their subscript as the case may be, the summation of everything will give us 0, as long as it doesn't have any charge on the radical. As long as it doesn't have any charge on the radical, the sum of everything here will give us 0 when you want to do calculations. So maybe you are asked to calculate the oxidation number of sulfur in this particular compound. By the time you're working on this thing, you equate everything to 0. That's the meaning of this thing where they talk say the algebraic sum of all elements in a compound now equal to 0. Now be the first one. What of the second one? I say I go do 2 in 1. The second one we say the algebraic sum of all elements, the algebraic sum of all elements making up, let me take it up a little, making up a radical. I've already explained what radical is on the other videos. You could just head over to my YouTube channel and search for that on this oxidation number. Is the charge of the radical. Don't worry, I'm going to explain this particular one in 1 second. Of the radical. Okay, so what this means is that, say for example, if I have something like say CO3 and maybe 2 minus. Sorry, that's no one there. Let me do that nicely. Good. Okay, so this is carbonated radical actually. So now you can see that the algebraic sum of all elements, when I say all element, I'm having carbon here, I'm having oxygen. How many of them? We have about 3 of this oxygen. All these elements put together plus this charge on it. All these elements put together gives us this CO3, then the charge on it. So this is where I was saying that the algebraic sum of all elements making up a radical is the charge of the radical. So the charge that is there, which is this one, becomes the answer. So you're going to equate the whole of this by -2. That's what it means. So with this particular one, you can be able to solve a lot of problems. Say for instance, if you're asked to find the oxidation number of sulfur in this SO4, this sulfate radical, like this, it means that if I'm looking for the oxidation number of sulfur, sulfur will then become X, which is the element I'm looking for, plus, remember I told you the oxidation number of oxygen in most states is -2. So -2 will multiply by this subscript, which is 4. Then you equate everything. This way I'll say equate everything by the charge. That's why I say the algebraic sum of all elements making up the radical is the charge of that radical. So it's equal to the charge of that radical. You can see that algebraic sum, meaning I'm adding up these things. So X now plus, by time you multiply 2 and -2 and 4, that gives you -8. And plus minus will give us minus. So yes, supposed to be minus. Okay, let's just put it as -8 like this, equal to -2. So now plus minus is minus. So if this 8 moves over to the other way, or add 8 to both sides of the equation, you have -2 plus 8, and that will give you about 6. I hope this is pretty simple. So thank you so much for enjoying this particular video. I'm going to be doing another one. I'm going to do plenty of this particular one, solving exercise by exercise, to make sure say everything clear for your eye. I hope you enjoyed this particular video. Thank you so much for watching. Subscribe to this YouTube channel, share this video, and make sure you hit the like button, and then comment whatever it is you want us to fix in the next question. Thank you. Hey, and welcome to this YouTube channel. So today I will be showing you how to fix this, how to calculate the oxidation number of sulfur in SO2. Now this is pretty simple. When you want to determine the oxidation state of a particular element, we need to take that particular element as X. Now because we want to check for the oxidation number of this sulfur, I will take this particular sulfur, which is this element, as X. So I'll just have X first. That's the first thing you must learn how to do. It is very, very important. Now, what is the next thing? The oxidation number of oxygen is what you start looking for. Keep in mind that the oxidation number of oxygen in most states is -2. The oxidation state of oxygen in most states, the oxidation number of oxygen in most states is -2, but with the exception of peroxide. For peroxide is -1. The oxidation state of oxygen for peroxide is -1. Keep that in mind. But this is not a peroxide. So this is one of the states that we are going to be talking about. So that means we're having X plus, we're going to be adding X plus the oxidation number of oxygen, which we have agreed to be -2 in this particular state. We're going to multiply that by this 2, which is a subscript under the oxygen. Multiply that by 2. When you do that, why do we multiply by 2? Is because it has 2 atoms of oxygen. This is 2 atoms of oxygen. If we have 4 atoms of oxygen, multiplied by 4. All right. So this forms a molecule. O sub 2 is a molecule. So we're going to multiply the oxidation state of oxygen by that particular 2, which gives us X plus -2 times 2 equals. Now, what we're going to be fixing here is 0. Very important, because it doesn't have any charge on it. So it's going to be 0. That's why I gave you a rule. The algebraic sum of all elements in this part, in the compound, is going to be 0. Okay, so what do we need to do? Let's work on this basic algebra. So you know that -2 times 2 gives us -4. So X plus -4. I prefer sometimes we put these things in brackets. It makes it looks a bit mature and interesting than just leaving it like that. Equals 0. I'm talking about mathematically. I prefer it that way. So now you can clearly say plus times minus, that will give us minus 4 equals 0. Finally, by the time you add 4 to both sides of the equation, why are we adding 4 to both sides? Because we want to eliminate this one to get x, which stands for sulfur. So you can see that minus 4 plus 4 will give you 0. Therefore, x will be equal to 0 plus 4 will give you plus 4. So the oxidation state or oxidation number of sulfur in this particular compound is positive 4. And I believe this video helped. Please like, share, and hit the subscribe button. Turn on the bell icon so that when I upload new video, you receive notification automatically. And until next time, I'll see you in the next one. Peace. Hello and welcome to my video tutorial on oxidation number in chemistry. So we're going to be looking for the oxidation number of sulfur in this particular compound. How do we work through this? It's pretty simple. Just recall that the oxidation number of hydrogen is +1. Oxidation of hydrogen, or the oxidation number of hydrogen is +1, except when you have some cases, like some exceptions. But just know that the oxidation number of hydrogen is +1. But we have 2 atoms of hydrogen in this case. So what do we need to do? That will be that we're going to multiply this +1 by 2, and that gives us +2. We've settled for this hydrogen. Then moving next to the oxygen or sulfur. Remember, the sulfur is what you're looking for, so we just give it as X. Then we have another one, oxygen. The oxidation number of oxygen in most states is -2. In most states is -2, except for peroxide. That's when you have it to be -1. So in this case, we have also a subscript. So that means we're having molecules of oxygen. We're going to multiply this -2 by 4. That will give us -8. So what's the next thing we need to do? Let's add up everything together. So technically, we're going to be saying 2 plus x minus 8. Equate everything to 0 because there is no charge on this particular compound. So equate it to 0. So what do we need to do? 2 minus 8 will give us -6. Equate that to 0. You're looking for x, which is sulfur. You add 6 to both sides. Positive sign will cancel out with that -6. Positive 6 will cancel out. So you add 6 to both sides. When you do that, what do we have? This cancels. X now will be equal to 0 plus 6 will give us +6. So this means that the oxidation number of sulfur in this particular compound, some people call it tetraoxosulfuric acid, or I just want to just call it a compound just the way it is +6. And I hope this particular video helps you. Please make sure to like this video, share this video, and then drop a comment if this makes sense to you. And let me know what you want me to do in the next section, in the next video. Until next time, please make sure to join our Telegram channel for more video. Hello my people, and welcome to chemistry video tutorial on oxidation. So this question say, what is the oxidation number of oxygen in H2O, which is water, and H2O2, which is peroxide, hydrogen peroxide? This is quite very simple. Following the rules I don't already teach you. I tell you, say the oxidation number of oxygen in most states now -2. So that means the oxidation state of oxygen in this particular compound like this now -2. That be the final answer. Then for peroxide, that be the exception where I say the oxidation number of oxygen in most states, this one follow for the state now -2. Exception of this peroxide. When you see peroxide, the oxidation of oxygen in that particular case now -1. That means for this peroxide, the oxidation state of oxygen now -1. If you follow up the rules what I don't give on these things, then you should be able to fix this within 1 second. I also this particular video explain everything we need to know about oxidation number of oxygen in this particular compound when they don't give you. Until next one, I'll see you. Like this particular video, share so that other students will benefit of it, and make sure to comment. Subscribe to the YouTube channel, turn on the bell icon so that when I upload new video, you receive notification. And thank me. You're welcome. Hello and welcome to oxidation number video tutorial. So in this particular video, I'm going to show you how to get the oxidation state of sulfur sulfur in this particular compound. This particular compound is what they call oleum. That's the name of this particular compound. But we're not really interested in the name. We want to get the oxidation number of sulfur in this particular case. Keep in mind, the oxidation state of hydrogen is +1. So hydrogen is +1. We're going to multiply that by this particular subscript, which is 2. Then you add to this particular S. Remember, you're looking for sulfur. So since you're looking for sulfur, that particular element you're looking for becomes X. So, but then you have a subscript of 2, so you're going to multiply that 1 by 2. Add it to the next one, oxygen. The oxidation state of oxygen in so many compounds, in most compounds, is -2. So, because we're having subscript of 7, molecule of oxygen, so we're going to say -2 times 7. Then finally, you're going to equate everything to 0. Why? Because this doesn't have any charge, so equate it to 0. So 1 by 2 will give us +2, plus x times 2 will give us 2x. Then -2 plus -2 times 7 will give us -14 equals 0. Now remember that plus times minus will give us minus. So you're having 2 minus 14, and that should give you -12. So you have 2x -12. Pay attention to the signs, they are very important. Plus times minus will give us minus. So you're going to add these ones that doesn't have x. That's why I'm just more like collecting like terms. So 2 minus 14 gives you -12. This 2x is still this one you're having equals 0. Now you're looking for this x. Keep in mind, not 2x. You're looking for x. So you're going to add 12 to both sides of the equation, or you can say this one crosses over to this side, as so many people will want to say, and that will give us +12. But I like to say add 12 to both sides, so this cancels. Then 0 plus 12 still give you 12, which is the same thing. So you divide both sides by 2, so you can get the sulfur you're looking for, which is represented as x. Therefore, x will be equal to, what is 12 divided by 2? The result will simply give you 6. That means the oxidation state of sulfur in this compound called oleum is 6. And I hope this video was helpful. Please make sure to share this particular video. Like this video, drop a comment if this makes sense to you, and make sure to subscribe to my YouTube channel. Turn on the bell icon so that when I upload new video, you receive notification. Until next time, I'm going to see you. My name is Instructor Alison. Welcome. Let me show you quickly how to find the oxidation state of sulfur in this particular sulfate radical. This is what we call sulfate radicals. Sulfate radical. So we want to calculate for the oxidation state of this particular sulfur in this particular compound. So this is very simple. The first thing we want to do is that the net charge of this particular compound, the net charge is going to be -2, not 0, because we're having charge here of -2. So what I mean is that since we're looking for the oxidation state of sulfur, we can say x, represent what you're looking for, that particular element, with x. Then plus, remember the oxidation state of oxygen in most states is -2. So -2 will multiply by this 4, which is subscript under this, meaning we have a molecule. It's a molecule of oxygen. So when you do that, you equate the whole thing. Instead of 0, it's going to be the charge we have in here, which is -2. So what do we need to do? -2 times 4 will give us -8. Plus minus is minus, so we have x minus 8 equal to -2. So by the time you add 8 to both sides of the equation, you can see that -8 plus 8 will be 0. Therefore, x, which is the sulfur you're looking for, will be equal to -2 plus 8 will give you 6. So the oxidation state of sulfur in this sulfate radical is 6. And I hope this particular video helps. Please consider to hit the subscribe button, like button, and also share this particular video to other learners. Until next time, I'll see you. My name is Instructor Alison. Peace and love.